Okay, and a good morning to everyone. And that was Fleetwood Mac, Don't Stop Thinking About Tomorrow. And the reason for that song this morning, this is the last week before finals. And so the tomorrow that's being referenced is how many days do we have class this week? We go all the way through Thursday, Monday through Thursday. We have the 4 days, including today. Next Monday, a week hence, the final. Okay, and that's at 10 a.m. for you.
So fast.
Yes, it's gone fast. So what we're going to do this week is review for the 3 days. Tomorrow, I will try to share with you your grade going into the final and what unit test you might redo. I've returned the simple closed curve test today. And so Thursday, we will not have a lecture. We will have testing on that day. That's the last test we'll take before the final. So it's just these 3 days, Monday through Wednesday, and we are going to do a review of 2 units each day. Today is going to be on counting and formulas, and that's what we're going to be looking at as we look at problems going back and forth from the board. And you need some paper out, and so the idea, I have some problems up here, and I'll probably take some time to first reference the problem. And so what I'm going to do, Will, is on the diagram. I want to focus on that, but don't go there yet. I need to get an eraser, get something here that I want to get rid of for a moment. And this is the first problem we have, and so let's go to the diagram. Now what I've tried to do, and this is a somewhat feeble attempt, to show you what's called a caliper. Now a caliper, like a plumber's wrench in a way, it has one part here that may be fixed, like one end of the jaw, and then this is on a knurled, you've seen plumber's wrenches, sometimes referred to as monkey wrenches, and there's a knob here you move. This jaw opens and closes. So you've brought this jaw across, and so the distance between the jaws is the diameter of that sphere. And I've told you that it's 6 meters. Now, if we wanted to change that in terms of something more realistic, maybe 6 centimeters. So I could say it's 6 centimeters across, and you need to realize that the diameter and the radius have this relationship. The radius is what? Half the diameter. So the diameter is 6 centimeters in this case. And so if the diameter is this, I want to know what the volume is. Well, to do the volume, we have to remember a formula. And that formula from what we did earlier, 4 over 3 times pi times r to the third. You know it has to be r cubed because you must have cubic something at the end. So if you have inches times inches times inches, or centimeters times centimeters times centimeters. So the real question, how do you handle the substitution and your answer? So will you try to provide for me what you believe the substitution should look like and how you're going to calculate it? So if you'll do that, we'll take a moment. And first, get the answer, show your substitution, use the calculator to find me the answer. I want to know the volume. So that's what you're going to be doing now. Now remember, your radius is at 3 centimeters because your diameter was at 6 centimeters. Okay? Yes, you may. Okay, I'm going to slide that over for you. Okay? Now, let's see what we can do here. How did you treat the 4 over 3? What can you do? You have 2 choices. Okay, so you use the 3 to cancel. So what is being suggested is 4 times 3.14, then 3 centimeters times 3 centimeters times 3 centimeters. What is the advantage of writing out the centimeters each time?
You won't forget them at the end.
I hope that you won't forget them at the end. Exactly. Because that means centimeter times centimeter times centimeter, which is centimeter cubed. Now, what can be done with the 3 that was under here? It can be canceled with one of those 3's. I like that. So, in essence, you're multiplying 36 times pi times 4. Now, if we didn't decide to do it that way, what would be an option?
Find the decimal.
The decimal for 4/3.
1.33.
Okay, now you have to be careful there to decide how many 3's you want to use. Because technically, how many 3's are there? They go forever.
The more you use, the more accurate.
The more 3's you put into the calculator, the more correct your answer will be. So if you're going to use the 1.33, I'd throw as many 3's as I can onto the calculator. Then multiply by your 3.14. Now again, remember that that is only pi to 2 digits after the decimal. Pi also goes forever. Even though at Thanksgiving, with enough people around the table, the pi is gone. But the pi that we have here, 3.14159, goes forever. So this is going to be a slight error we've introduced. And then you could just say 3 cubed is 27, and cubic centimeters is cc. That's the abbreviation for cubic centimeters. So it depends on which formula you use for your answer. So Adrian, what are you getting on your calculator?
For final answer is 1113.14. I'm sorry, yeah, 113.1.
113, not 1113. Okay, 113.04 cubic centimeters. And that's using 1.33, as many as you can. If you just use 2 3's, does it change the answer? Let's check that.
It's 112.
Okay, so if you went 1.33, you're getting what? 112.74 cubic centimeters. Now that doesn't make that answer wrong. It's just not as good as the 113.04. How do you avoid dealing with that? You could, even if our radius had not canceled, you could still multiply everything on top and at the end divide by 3. That'll give you the best answer. Any questions there? Okay, while we're still on formulas, I'm going to leave that right where it is, Will, for just a moment. And then what I'm going to do is come over here and look at this diagram in a moment. Let's see what I want to leave up here or not leave up here. So let's see what we can do here. Okay. So let's cut to this sideboard now. Not the side, but the front right. This is a new diagram. This is a combo, if you will. It involves a triangle, a rectangle, and a half circle. And I want the area for the whole object. Now note, the rectangle portion is 8 inches by 4 inches. And I probably can do a little better job of drawing in that leg of the triangle. So let's see if I can do just a little better job there. And I'm dashing that leg. And then the idea is that this diagonal of the triangle comes up to the corner of the rectangle. Let's see if I can clean this up just a little bit. So the diagonal of that right triangle is 5 inches. The height of that triangle is 4 inches, and the base is 3 inches. And then this right here is considered a right angle. And so this also satisfies what? When we have a right triangle, what theorem do we talk about? You're close. It starts like something like pi, but not quite. Pythagoras. Okay, Pythagoras.
Close.
So you're close. And Pythagorean theorem says that this 3 squared added to the 4 squared gives you the 5 squared, so I know that's a right angle in this triangle, a 90-degree angle. So again, 3 squared plus 4 squared equals 5 squared. We don't have to worry about the units for that. But again, that was Pythagorean theorem. Okay, we have 3 different formulas we have to do. We want the area of the rectangle, the area of the triangle, and these are just formulas you're supposed to have memorized. And then this is the one we have to be a little bit careful about because I don't want the area of a whole circle. I want what? The area of the half circle. Because this is on this side, and again, probably if I did this just a little bit neater here, see if I can clean that up just a bit so it looks a little more reasonable. That as this circle comes up into the rectangle, this is just a half circle I have. So I need to find some areas. I'll have you do that for a moment. I'm going to walk off camera just for a moment so you can see the formulas and the diagram. And I want the area of the whole object. And I've given you the 3 different formulas. You want the substitutions, include the units, and the area, the grand area at the end. Okay, so we're just going to leave that up on the screen. Okay, leave that there for a moment. Just giving you some chance to do that. Hopefully, you're getting some answers there that are acceptable. Anybody have a grand answer yet? You might argue everybody's answer is grand. Just giving you some more time to do that. Okay, at the end you're going to add all of them together. So yes, you're going to add. Okay, what is your answer? 6312. What? Inches only? Are you finding area, perimeter, or volume? Area. So area should be square inches. Okay. 63.12. So I should probably go ahead and put the 12 in there, even though I don't have much room. So I'll clean that up. We have a disclaimer. Could be wrong. Okay, so 63.12 square inches. Let's see what we have. The area of the rectangle. The rectangle has a length of 8 inches times, and I again like writing the inches in, times the width of 4 inches. And you can see, since I have inch times inch, I have to have square inches. So this is 32 inches squared. You see the units twice, so you write the exponent with the in to the second. Or you could have said in ins. Early on in algebra, by the way, instead of saying a squared or r squared, they said RR. Because it was just as short to write r times r as it was r with the 2. So r squared would be RR. Sound like a seal at Monterey. No fish at all, huh? Okay, what about the area of my triangle? Well, I'm going to write the 1/2, and then I have a base of 3 inches and a height of 4 inches. I don't use the 5, which is the diagonal. Now, technically these are over 1, correct? So what can I do? I can cancel this 2 with this 4. When I do that, I'm going to have what? 6 inches to the 2nd power. 6 square inches. So far I have up to 38, correct? Okay, now, what about this area of my triangle? Pi is 3.14. So I'm going to write that out at 3.14. The radius, and be careful, because I gave you what? Up here that the distance across was 8 inches, so this diameter was 8 inches. The radius is 4 inches. So I have 4 inches times 4 inches, and that's all over 2. So what can I do? Cancel one of these. So I have 8 times 3.14 ins, or inches squared. And what do you have for that, Teresa? 25.12 inches squared. So that means I need to take this 25.12. So I like that 0.12 up there. So I have 25 plus 38. 25 and 38 is 63. So 63.12 inches squared is a correct answer. Okay, question.
On the triangle, I've used the 5.
But the 5 is a diagonal. And when you do your triangle, the question is about the 5 in the triangle. Because I have base times height, I don't use the diagonal. So I'm going to take base, which is 3 inches, times the height, which is 4 inches, and then divide by the 2. Okay? When do I use the diagonal? When I find the what? The perimeter of a triangle. Okay? Well, let me come back center here for a moment for Ernie to free up a or not Ernie. Will's doing it now, bouncing back and forth with camera operators. Will, would you come back to that same diagram to the side, underneath the clock, to the left side? Since Adrian brings up the question of the diagonal, I'll have Will go to that, bring that in just a little bit tighter, just on that diagram. Okay, that looks good. Now, in this diagram, what I'm asking you to do is find the perimeter. But you have to be careful. It's the same diagram, not nearly as neat as the one on the front board. And notice I've tried to go ahead and make this look a little bit more like a curb or something. Think of this as a curb around a grassed area. So grass is growing inside all this, and you are not allowed to walk on the grass. So you're going to find the perimeter around this and not walk on the grass. So that's our challenge as you do that. Okay? Now also note, and Ernie, Will, said Ernie for an hour now, having to adjust. Will, as we come over to the side, let's pick up this diagram for a moment. This is an appropriate way to find the perimeter of a rectangle if all I gave you was a rectangle. That is, if it was an 8 by 4, the perimeter of this rectangle would be 2 times the length plus 2 times the width, and you would get 24 inches. But when I come back to the diagram again, notice I'm not walking on two sides of this rectangle. So what you have to think about is simply keeping track like an odometer. So if I start right here at this little corner and go this way, following the arrows as I go along, I just want to keep track of how far I've gone when I finally get done. So that's what I want you to do. And remember that the circumference of a circle is what? Formula. Circumference of a circle. I need a formula for the circumference. We're pulling a blank. 2 times what? Pi times the radius. 2 pi r. What's an alternate formula for the circumference of that circle? 2 times r gives you what? I think, Adrian, this is what you were thinking of. 2 times r gives you the diameter. So you could have said pi times d. But we'll just use this formula. Do I want the circumference of that whole circle? Half the circle. So I'm going to divide this by 2, divide this by 2. So the 2's cancel, and I'm just going to take the value pi times the radius. So what I want you to do is find me the perimeter. And by the way, perimeter is what we usually say when you're going around triangles and rectangles. Circumference when we're going around a circle or a half circle. I'm just using the generic find the perimeter. So let me walk off camera there. We'll bring that in just a little bit tighter so people who are watching that this afternoon have a little better idea of what they're doing with it. Again, you're going to keep track of your walk. So you're walking around this shape. Well, you do some multiplication, but for the most part add. Just keep in mind that you aren't walking on some sides of the rectangle, and you're not walking on some sides of the triangle. So you have to be cautious there. So we'll let you keep track of your walk. So you're going for a walk, walking around this shape. That's what you've got to remember. You're taking a walk around the shape. Somebody have an answer for me that we can check against? 41.12? Okay, I've got a 41.12 for the perimeter. That's my first estimate. Is it inches or square inches? It should just be inches because you aren't dealing with area. You're dealing with perimeter. Okay, let's see how we did it. Can you tell me your justification for that answer? Well, let's start here. If I'm going to start right here. A 3 inches, then a 5 inches, then an 8 inches, then another 4 inches. So we're right to here at this point. So we did 3, 5, 8, and 4. This was 4 here, opposite side of that rectangle. Okay, what did you have down here? 3.14 times 4. But we already did what? Divided by 2 right here. Well, I know, but that would be half the circumference. So I've already taken care of that. So this should be 12.56. Okay, so that's going to change. This becomes 12.56 inches. So let's see what we have. There's 8, and 8 is 16 and 20. So it looks to me like we have 32.56. Do we agree? 32.56 inches this time, where before we had square inches. So this total is going to be 32.56 inches. Okay? Okay, I have one more problem. Let me come off here, just leave that for a moment, so those of you taking notes can get what you need there. And then I'm going to come back center on this, Will, if you would please. And I'm going to give you one more problem with formulas, and then we're going to the counting unit. So we have one more problem with formulas. Okay, I have on the sideboard a problem stated for you. And that's where we're going to go next. So, Will, if you bring up what we've got there. So my problem was, and maybe let's just focus on the first part up here. So bring in enough where you can pick up the top here, maybe go down to about here. So bring that a little bit tighter. There we go. And then over to the left just a little bit, the other left. Thank you. So we have given a right triangle. Legs of 5 inches and 12 inches. Okay, so this is 5 inches here, 12 inches here, and a diagonal called the hypotenuse. And I'm telling you that's 13 inches. So in a problem like this, here are some of the things I would ask you to do, and I've done part of them for you because I was a little bit concerned about time. Draw the diagram, label it. Okay, that's what we've done using units. So I've drawn a right triangle. It's 12 inches for the height. The base I used at 5. Those are called the legs. And you could have reversed that. It doesn't matter. Somebody might ask, well, isn't the base usually a shorter number? Not necessarily. The diagonal will be larger than each leg. Okay, now, at this point, here's what I want you to find. So we come down just a little bit now, Will, for me. A little bit more, just to here. I want you to find the area and the perimeter and defend the Pythagorean theorem. So to do this, I want you to go ahead and show the formulas. Let's move over to the right just a little bit. And I'll come off camera. Show the formulas, substitutions, and answers. Now, since we've already done this earlier, the Pythagorean theorem, since it was a 5, 12, 13, 5 squared is 25, 12 squared is 144, 13 squared is 169. So let's just come up to the right part of that with the diagram showing this part here, what I want you to find. And then find the area and the, let's see, I have you finding the area and perimeter. So the area and perimeter of that shape. So let's see if we can get that done in just a few minutes. Area and perimeter. Remember, this time of perimeter, you're using all 3 sides. So we'll give you a chance to write your formula, show the substitution, and then give your answer. So formula, substitution, and answer. Giving you just a little bit more time. Okay, who has the area? Okay, give me who has the area? How many? Only one of you so far. Okay, we're going to wait. Anybody have the perimeter? Assume if you have the area and perimeter at the same time. Okay, 2 of you with area and perimeter now. Still waiting. You need the formulas. Maybe I can start with the formulas over here. Okay, so if we're going to write the formula for the area is going to be 1/2 times the base times the height. We've already done a problem like that. So what does that give us? 1/2 times the 5 times the 12, and that's 30 what? Square inches. Thank you. So 5 times the 12. What about the perimeter formula?
Base times height times diameter.
Now, be careful. Not times. You're going to add base plus height, and the D is for diagonal this time, not diameter. So we have 5 inches plus my 12 inches plus my 13 inches, and what do I get? 30 what? Just inches. The numbers are the same numerically, but one, the area, is in square inches, and the perimeter is in inches. Give you a chance to write that down while you're still looking at it. Okay, Will, come back to me in this one. And now I'd like you to go to in between where you were, a little bit to the left where it says count to 100 in base 2. We're going into the counting unit now. So a new problem. We're in the counting unit. Count to 100 base 2. What are the only digits you can use here? Okay, hint. Only use 0 and 1. Okay, let's pull out of there just a little bit now. Give me a little more space. Okay, that looks pretty good. Adrian, you started this. Let's go. 1, 1, 0, 1, 1, 1, 0, 0. Very good. That was in base 2. Yeah, we don't want to start with 0. We'll always start with 1. So 1, 1, 0, 1, 1, and 1, 0, 0. What if we said in base 3? Let's give it another shot. Somebody else. In base 3. Counting. Starting at 1 and going to 100. Okay, 1, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2, 1, 0, 0. Nicely done. That's in base 3. Okay, we're going to do another counting problem. Will, with camera 1, will you find that middle problem in the front board? Now this is using expanded notation to write using powers of the base, and my number is 10321 in base 4. I'd like you to do this in expanded notation. Expanded notation. So I'm going to need what here? What's my hint? Well, powers of the base, but what's the hint? If I were to give you a hint. I'm wanting you to do expanded notation. What do you need?
To write it out.
But what do you need? My hint was going to be find place values. That would be my hint. So let me walk off camera. And so that's your hint. Find place values. You're going to need that to write this in expanded notation. Base 4, expanded notation. Giving you a chance to just write that out. Remember, I want powers of the base for your place values, so be careful. I'm going to write some, just draw in some place value lines here. So let me just do this to keep them fairly neat. Okay. What is my first place value always in the far right?
1.
It's the base to the 0 power, but it's typically just a 1. Then my next to the left is always what? Well, base 10, it would be a 10, but in base 4, it would be a 4. And then what do I multiply by as I go across to the left?
4.
By the base. So what will my next place value be with exponents?
16.
With exponents.
4 to the 2nd.
4 to the 2nd. This was 4 to the 1st. I said powers of the base. So this time I want it with 4 to the second, then 4 to the third, and 4 to the fourth. And technically the first one, 4 to the 0. So I'll write my number in the place I have here. So I'm going to have a 1, 0, 3, 2, 1. So here's my 1, my 0, my 3, my 2, and my 1. Now how do I get expanded notation?
1 times 4 to the 5th.
Be careful.
4 to the 4th.
I multiply the digit times its place value. So let's go up to the just a little bit higher now so I get just baseline here. Thank you. So I have 1 times 4 to the 4th plus 0 times 4 to the 3rd plus 3 times 4 to the 2nd, agreed, plus 2 times 4 to the 1st plus 1 times 4 to the 0, or 1 times 1. That is an expanded notation using powers of the base. What is this equal to? If you now find the base 10 number, what are you going to do?
Find the value of it.
What is it? Give me the base 10 number. Otherwise, if you multiply this out and add it together, what do you get? So I want to have the base 10 number for 1, 0, 3, 2, 1, base 4. I want to know what it is in base 10. What is 4 to the 4th, by the way? 4 times 4 times 4 times 4. 256, and I have one of those, correct? So I have 256 here. I have 0, whatever that is. What's 4 squared? In your head.
16.
4 times 4, 16, and I have 3 of those. So that's 48 plus 8 plus 1. What do I get? What will this give me?
313.
Well, I have 56, 57, so that looks like that's going to end at a 3 and carry a 1 and carry another one. So 313, is that correct? Base 10. So 313 is 10321, base 4. But a note, the hint, place value. That was the key. Okay. Now, given that, let me give you another number. 144 as a base 10 numbers. We're going to work backwards. See, here I started with what? 10321, and I wanted you to give me the base 10. This time I'm going to give you the base 10, and you're going to tell me what it is in a different base. My number, 144, 12 dozen, which is a gross. And I want you to write that as a base 3 number, which is what Will now has on the screen for you. So 144, base 10, we'll just leave that up there. You want to write this in base 3. In base 3. Hint, place values again. So I'm giving you the same hint as before. We're going to use place values. Now I'm just staying out of camera for a moment, off camera, so that you can focus on the problem. Hint, place values. We'll just leave that there for a little bit longer. Make sure you have time enough to work on it. Okay, if we're going to do place values, we might as well get a place value chart here. And this time we're in what base? 3, correct? So what do I start with in the far right? A 1. Always your 1s. Then comes the what? The base itself, which is 3. And then I multiply by what? By 3 as I go to the left. So that's going to give me what in the next spot? A 9, and then a 27, and then a 81, and what? After the 81? 243. Do I need to worry about the 243? Why don't I? Okay, it's bigger than the 144, so I can scratch the 243. So I need to know how many 81s I'm using there. How can I find that? What are my choices that I can use there to do it? What are my choices? Divide or subtract, agreed? So I can have those as my choices. So if I divide 81 into 144, it goes one time and leaves what when I subtract? Folks? 63, agreed? Okay, can I divide by 81 again? No, so I have 181. So I go to the 27. Okay, 27 into 63. Goes twice. Give me a 54. 9 left. So I know I have two 27s now. So I have 181, two 27s, and my next place value was 9. So I do what? 9 into 9, and that goes once. No remainder. So I have one group of 9. And then 0 3s, 0 1s. So my answer, 1, 2, 1, 0, 0. Base 3. Okay. A new problem. As we just, let's see, let's follow me over a little. Oh, I think I'll stay where I am, Will. Let's come back over here. Next number. Find next number. I'll use that for number. Here is my number in base. Let's see, in base 8. My number is 777, and I want the next number in base 8. Don't say it, just write it for the moment, please. So don't say it, I just want you to write it for me. Give you a chance to write it. This is a good problem to decide if you know what's happening in counting. Because if you have the answer to this immediately, you know what you're doing, I think. If you're struggling with this one, you need to review. So that brings up the question, what am I expecting you to do in homework this evening? Well, certainly study. One thing would be to review all the formulas, because remember, you have to have them memorized. So I would be looking at the formula unit tonight and trying to write out all the formulas I need. Then in counting, you need to look at the problems in that unit again and try to redo some of them, because you have 4 or 5, most likely 5 problems in counting, and they're worth about 4 points each, 3 to 4 points each. That's a letter grade just in the counting unit on the final. Okay, does somebody have the answer for me? Okay, 1, 0, 0, 0. That's not 1,000. So your answer is 1, 0, 0, 0, base 8. And that's a nice, easy problem to write down for a test where you don't have to spend much time, but you have to do what? Know what you're doing. Now, Will, I'm going to walk off camera here for a moment so people can just look at that for a moment. I'm going to go back to center up front and talk about the final. Now, what I have in mind in the final would be for each unit in the Orange Book, and that's 7 units, at least 4 questions per unit. And I think I'm inclined to run somewhere around 30 problems for the final. So that means 7 units times 4 would be 28, and then I toss 2 in that are additional, so maybe an extra counting problem, something of that nature. You need to spend time redoing problems. Now notice how I'm saying that. It's not enough to simply read what you've done and to go back through the Orange Book and look at all the problems you've done. What you need to do is redo some of those problems, like I've been doing on the board today. And so what your focus should be this evening, in addition to memorizing the formulas again and spending time in the counting unit, try to do a problem in each area. Try to do some problems where you have an example that's been done, or you have a test question you've done before. Redo it without looking at your work. I don't mean reread it. I mean redo it. There's a big difference. Make sure you have spent your time doing the problems. Now, we did the first 2 units alphabetically. That was counting and formulas. What is on the agenda for tomorrow? After formulas came, what? I think it's the how much unit, isn't it? Yeah. And after the how much, what? Large numbers and scientific notation. So tomorrow we're going to review how much dimensional analysis, look at large numbers and scientific notation, and I guess I should say large and very small numbers, because we use scientific notation for both. Will, I finally got it straight who's doing the camera this hour. So we're going to go back with Fleetwood Mac, and don't stop thinking about tomorrow. Have a great